Okay, so we're talking about wave properties. The first question on your worksheet says, draw a wave that shows two complete cycles and label one wavelength on that drawing. So, if this was basically my normal line, and I start my wave over here, I'm going to go up, down, one cycle, right? So how many cycles do I need? 2. Up, down, 2 cycles. Is that good? So what is the wavelength? Yes. You can do it from here to here. You can do it from this point to this point, and you can say this is my wavelength. As long as your points are aligned a complete wavelength, you can say this is my wavelength. Okay? Now, any questions at this point? So quickly, just so I can have this on my video, who can tell me where the amplitude would be? Where would your amplitude be? Yeah. From the straight line up, or that would be your A, or from the straight line down. What would be my wave height? What would be my wave height, Wyatt? We'll come back, Brent. Were you here yesterday? Okay. So this would be your wave height. It's the height of the wave. Okay? What else did we mention when it came to wave? What do we call this point? A trough. And what do we call this point? A crest. Awesome. Okay. Now, the second question is asking us to draw a wave that has twice the frequency. I'm going to pause the video and I'm going to give you enough time to try to do that on your paper with your partner. So we said we're going to draw a wave that has twice the frequency. When we say twice the frequency as this exact one, we know that we want to use the same exact distance, but twice the frequency. So how can I draw twice the frequency? More waves. How many more waves? 2 more. Twice as much. Okay? So this was a 1 set. And then we'll do another set. Sorry, it's not as good as it's supposed to be. Well, I think we are along the same side, right? All right. So we should be close enough. Okay, so with this in mind, what would be the wavelength in this case? So if I'm looking at the wavelength, take a look. So it should be what? It should be what compared to the top one? Almost half as much as the top wavelength, exactly. Okay, and that is because in one wave on the top, we have 2 waves on the bottom. So the length of the wave on the bottom is half as much as the top. We're good? Okay, so the third question says, if 2 waves of different frequencies, so we have different frequencies, are traveling through the same medium, what do you know about the speed of those waves and why? So if I'm looking at these 2 pictures and I say, okay, I have 2 waves. They are different frequencies, but we have, the same medium. What can you tell me about their speed? I want you to look back yesterday and try to remember when we talked about the speed formula. What did the speed formula say? Do you have your sheet in front of you? Do you guys remember? Okay, so frequency times your wavelength. So V is equal to your frequency times your wavelength. Okay, if I am going to consider the top, and I'm gonna change my color so you'll identify it. The top wave, and I'm gonna say how many. The frequency of this wave is how many? How frequent? How often do we have a wave? We have 2, right? So my frequency is equal to 2. Just looking at it, we know it's 2. In this amount of time, okay? In this amount of distance, we have 2 waves, right? What is my wavelength? We said it's 1, right? This is 1. I'm going to change my color. I'm going to look at the one on the bottom. I'm still looking at the same distance. How frequent was this? 1, right? 2, 3, 4. So I have a frequency of 4. But then my wavelength is, we said it's half as much, right? So my wavelength is what? 0.5. So let me ask you this question. If the speed says frequency times wavelength, am I having a different answer? No, it's the same answer. So you should always keep in mind that as long as we're in the same medium, okay? Same medium. Guess what? The speed remains the same. Regardless of what? Of the frequency. All right, so the question said if wave A has a higher frequency than wave B in the same medium, what does that tell you about how the wavelength of wave A must compare to the wavelength of wave B? So same medium, we said, always tells us that it is same speed. So speed did not change. But what does it tell you if I have a higher frequency? Shorter wavelength. Exactly. All you have to do is compare these two. Okay? So when I had a higher frequency, and I'm going to use the red, higher frequency, what happened to my wavelength? That's all I'm asking you. It was shorter. Easy enough? Thumbs up? Show me. Sideways if we're good? All right. So number 5 said, okay, so in general, waves with higher frequencies have shorter wavelengths. And this is because the pulse happens more frequently, and therefore any one pulse will have traveled, in terms of distance, less distance before the next pulse. And so you have, it says, as frequency increases, wavelength decreases. Any questions so far? Okay, so let's do the next one. The next one said, in general, waves with lower frequencies, so we're looking at the one on top right now, lower frequencies have longer wavelengths. You can see it right here. And this is because the pulse happens less frequent. There's less frequent than it is over here. Okay? And therefore, any one pulse will have traveled more distance to the next pulse before the next pulse is generated. So, as frequency decreases, wavelength increases. We're good? So as frequency decreases, there are 2 here, okay? Wavelength increases. Frequency decreases, increases over here, we saw a shorter wavelength. We're good? All right, so that's for the front page. Okay, so question said, if you want to change the speed of a wave, what is the only way to accomplish this? You change the medium. And why? Because properties only change based on what? On the medium. Okay? Properties of a wave change based on the medium. Number 8 said, if you have a spring or a string, and you want to increase the speed of the wave on that spring or string, what 2 things can you do to the spring or string to make that happen? I want you to take a minute or so with your elbow partner and discuss it and see if you can figure out the 2 things that you can do in order for you to increase the speed. Okay, so again, I bet that was fun. So what happens? We said if we have a spring or a string and we were able to increase the speed by, number 1, increasing the tension, which increases the force and thus the acceleration of the particles in the medium. So when you have more force in your string, you have an acceleration of the particles. And then the second way of doing this is you decrease the mass, which means the same force will cause the particles in the medium to accelerate greater. Okay, so make sure you write that down. Number 9 said, a wave oscillating with the same frequency is sent through a medium that has a higher wave speed. This means that the same time between pulses, each pulse will travel more or less distance. So let's think about it a little bit. So a wave oscillating with the same frequency is sent through a medium that has a higher speed. So it's a different speed, same frequency, but different speed. It's a higher speed. This means that the same time between the pulses, each pulse will travel more distance. Each pulse is going to travel more distance because it's a higher speed. Okay? So more distance. Therefore, even though it's the same frequency, the wavelength will be longer. Okay? Higher speed. So more distance, longer wavelength. Is that okay, or do you want me to go over it? We're good? So it's simply because we have a higher speed. And the difference is being told to you by telling you that it's a different medium that has a higher speed. Okay, so as the speed increases, what happens to the wavelength? Increases. Speed increases. So the wavelength increases. A wave oscillating with the same frequency. Now we're talking about same frequency. That's number 10. Is sent through a medium that has a lower wave speed. This means that the same time between pulses, each pulse will be less, because lower speed, it's going to be less distance. Therefore, even though it's the same frequency, the wavelength is going to be shorter. Okay? So, with this in mind, as the speed decreases, what happens to the wavelength? It decreases. Awesome. So I'm going to stop right here. Okay. Again, it says y based on the equation v is equal to lambda times f. Makes sense? We said because if v is constant, v is the same, as frequency increases, wavelengths decreases. Okay? And then we say if frequency is the same as the wave speed goes up, wavelength also goes up. Okay? Can you see this? No? All right, I'm going to zoom it in. I should use a thicker line. So again, if V is the same as the frequency increases, wavelength decreases, and if F is remaining the same, the frequency is remaining the same, as V increases, wavelength increases as well. And this is basically explaining this right there. We're good? Okay. Now, the last part of this is that table. Let me go ahead to write this down. So, on your table, you were asked speed, frequency, and one more, wavelength. Okay? And then you were given options of keeping something the same or moving another around, and what happens. So basically you're using the information we just ended up filling out to change these things a little bit around. So we said I'm gonna do a couple, and then I'm gonna leave you to do the rest. So if the speed is the same and we increase the frequency by twice as much, what happens to lambda? What happens to the wavelength? Speed is the same, okay? And the frequency is twice as much. Remember when we had earlier, we increased the frequency, so it was 1, 2, 3, 4. What happened to the wavelength? It got shorter, so this is half. We're good? Okay, so the next part said yes. Okay, 1 through 10, your phones. We're going to do one more, that way you can do the rest at home. If the speed is the same and your frequency is half as much. Half as much. What happens to the wavelength? So it's like the one we did right before this one. Frequency is half as much. What happens to the wavelength? It is twice as much. So twice as much as this, because that's where the comparison is.